So today we're doing electrochemistry. See, electrochemistry is something that I personally struggle with. So all I gotta say is focus up, watch the recording, and learn with Mr. Chin because he's the GOAT.
Alright guys, now let's look at your E cell potential. So guys, how do you define cell potential? First, you need to know the definition. So the definition stands for potential difference between two half cell under standard condition. And guys, the difference between the E naught value of two half cell, we call it as the cell potential. Yeah. Bye-bye. See ya. Alright guys, next.
Bye.
Okay, how do we get your E cell, right? Your E cell formula is E. Okay, I'm not so sure about your school formula, but I'm going to give you a new one. So most probably your school formula is more a reductant minus oxidant or reductant minus oxidation. Now, I'm going to use a more general one. More positive value minus a less positive value. That's it.
I learned this too.
You learn in school, maybe.
Oh,
yeah. If your school teacher is as lazy as me, then we'll give you this formula.
Oh, I mean, my teacher taught reduction minus.
Reduction. Usually the school is reduction minus oxidation. But no, same in school. Your school also more positive minus less positive. Means your teacher is as lazy as me. A good teacher. Yeah. Okay, so guys, this formula, right? Okay, if you apply this formula, okay, that's a catch in it. So the catch is this formula will always gives a positive value. Okay, so if you were to apply this formula, right, your answer is always positive. It will never be negative. Okay, so that's the catch. You will never get a negative value from this equation. Okay. Hey guys, next. Okay, I'm going to show you a 3-step hack to calculate E cell and forming your overall equation. So the first step, right, is to write what happened? This baby girl. Okay, is to write the more positive equation on top and last positive equation at the bottom up. Guys, today we'll get electrochem done, yeah. Second, I want you guys to draw a clockwise arrow. Third step. Combine and cancel out the electrons. Alright guys, example. You see we have a half cell here, right? Okay, we have a half cell, silver half cell, zinc half cell. When you combine it, right, the cell potential is 1.56. How do we get this formula, right? Okay, you can use your school teacher method, reductant minus oxidation. It's okay, it's right. Of course, it's correct. But my method, I'm gonna do a no-brainer. It's just more positive value minus a less positive value. That's it. Okay, it's always like that. So you just take the more positive value, which is 0.86, 0.8, minus off, this is last positive value, 1.56 would done. That's the lazy people method. Alright guys, when you're applying my formula, yeah, okay, let's say if you're applying my formula, you don't need to flip one, yeah. You don't need to flip any of the value. Remember, yeah, if you apply this formula, do not flip any E naught value. But if you are using your school teacher method, maybe you need to flip. Okay, my method is just a very generic one. You just apply, okay, you don't need to flip the number, just copy and paste the number, that's it. Okay, so remember, yeah, but if you're using your school teacher method, don't go and apply it here. It will not work, yeah, because your school teacher might teach you guys how to flip the value. No, if you're applying this, don't flip, just copy and paste anything. whichever is more positive pays, less negative pays, that's the value. Okay, that's it. A no-brainer one. This formula is very no-brainer. It's that simple. Okay. But if you were to flip, don't use my method, please. Alright, guys, next page. So I can say that, right, the value of between Ag plus and Ag half cell is more positive. So when Ag half cell is more positive, right, Ag half cell is the cathode, right, because cathode reduction. More positive always undergo reduction. And it's the cathode. And zinc is the anode, always undergo oxidation. No, I think if we have time today, we're going to do more questions in this chapter. We're not moving on to a new one. All right, guys, next. Forming overall equation. Guys, to form overall equation, very simple. First step is to arrange whichever value that is more positive on top, whichever that is less positive at the bottom. Second step, draw a clockwise arrow. Just draw a clockwise arrow like that. Okay, and guys, you see that, right? Ag plus will turn into Ag. Am I right? Correct. Follow the arrow. Dun, dun. Zinc will turn into Zn2 plus. That's it. Okay, draw a clockwise arrow, follow through the arrow. Ag plus turn into Ag, Zn turns into Zn2 plus. That's it. Okay. Okay, guys, before that, you have to balance the electron also. Do you see you have two electrons here? This is only one. So you multiply the top equation by 2. And that's your final answer. Okay, know how to apply? All right, guys, next. Before we move on, we have this question. All right, guys. My formula is PRR around AC. Remember, yeah? We have three formula, PRR around AC. What AC stand for? Electron always flow from anode to cathode, please. All right, guys. Do you see that this value is more positive? PRR. Next, positive always cathode reduction. All right. So I know that this is my cathode, this is my anode. So the electron will flow here. Get me? And guys, where the electrons flow, right? Electrons always move through the external circuit, which is the external wire. Okay, so they do not travel through the short bridge, remember, yeah? Short bridge is for ions, it's never for electrons. So, is it just electron flow from AC or current? No, current always flow the opposite way. When electrons flow from anode to cathode, current flow from cathode to anode. But you don't need to know your current. Current is physics. In chemistry, you just need to know the electrons flow, which is anode to cathode. All right, guys, now I want you guys to do this question. maybe, sorry guys, the next question 3. Let's go, Q3. All right, guys, I go refill water. When I'm back, I want answer from you here. You follow me, I cannot. Bro, you think what? I'm a cut, bro. I'm not a cut.
Why? There.
Okay, what's your answer?
Water died, bro. It has fucking.
Okay, guys, what's your answer? Come, hey, help me close the door, la. Thank you so much.
You can board it. You can board it. I asked you one. What's the name?
All right, guys, let's go. What's your E cell? Your E cell is a no-brainer formula, which is 1.33 minus 0.155. More positive minus less positive. That's it. Okay, 1.18. That's it. Okay, just apply the formula. Done. All right, guys. Next, I want my overall equation. Where's my overall equation, guys? Okay, since it's already arranged in more positive on top, less positive at the bottom, I just have to draw my clockwise arrow, and the electron here has to be balanced by multiplying 3. So your answer is Cr2072 minus plus 14H plus 3 Sn2 plus turns into 2Cr3 plus 7H2O 3 Sn4 plus. Done. Okay, it's already balanced. Next, I want you guys to tell me the direction of electron flow. So the direction of electron, so why is it minus 0.51? 0.15, sorry, bro. My bad. Yeah, 0.15, my bad. Okay, guys, next. How do you find the electron flow? Again, this is more positive. So this is my PRR, and PRR is always cathode reduction. So this is my cathode, and this is my anode. So electrons flow from here. Done. Okay, so from anode to cathode, yeah, through the external wire. All right, guys, once done, next page, page 32. All right, guys, page 35. You want to start? All right, guys, 35, let's go. Okay, let's go. So using E naught value to predict feasibility. Guys, now, the moment you see the word predict feasibility, is a different topic now, yeah, guys. It's a totally different topic with total different method. Okay, so we're going to use another method to solve it. So guys, again, when you have any reaction with a positive E cell, is thermodynamically feasible. Bro, tongue tied. Okay, so positive E cell, thermodynamically feasible. But if it's negative, the reaction is not feasible. All right, guys, now I want you guys to highlight this. If you were to ask to predict feasibility, never use your E cell formula, please. Your E cell formula is for E cell. Okay, so if it's feasibility, it's never your E cell formula, please, yeah. So I will show you a new set of working to predict feasibility. No, the second one, right? Thank you. Right, guys, now we have a 3-step hack here. To predict feasibility, guys, first, the most important step, ensure the species we are testing are on left hand side. Okay, the species that we are testing must be on the left hand side, must be. Okay, second, if you swap the direction, you have to change the sign of your E naught. The step, guys, you see here, now you have to add up your E naught 1 plus E naught 2 to find E feasibility. That's it. Okay, guys, from this part onwards, my method and the entire syllabus method is totally different. Yeah, let me tell you first. Okay, if you are using your school teacher method, you stick your school teacher method. You just listen for fun. Because my question, right, I purposely designed this note to tackle all the past year question, because past year question has a lot of questions like that. Okay, so later we're gonna try some past year questions. Again, whatever that you're learning now is totally different compared to your school. I know. Yeah. Because this is a brand new part, sort of created by myself. Yeah. All right, guys, now the first one. Okay. Let's say if I want to compare copper, okay, I want to test whether a copper and a nitrate ion, is there a reaction? All right, guys, my first step, right? Okay, always remember, yeah, the first step is to ensure the species that we are testing are on the left hand side. Where's copper, guys? Copper is found here. Can you see that? So you can highlight your copper, and your nitrate ion is found here already. Okay, so guys, first step, you have to ensure that everything is on the left hand side. Do you see that your copper is not on your left hand side? So what you need to do, please swap them. So guys, you see, I'm swapping my first equation now. Yeah, if I swap my first equation, my E naught value will swap also. Okay, so right now it changes into a negative sign. Can see that? Alright, guys, second is to get your second equation. You don't have to flip, right? It's already the same, right? Just rewrite it one more time. Because you don't need to flip it, right? It's already on your left hand side. Correct. That's your E naught 2. Does the mark scheme allow this? The mark scheme, there's no working in the mark scheme. The thing is, there's no working required. Okay, so you just have to answer whether is it feasible or not feasible, and they just want the overall equation. Of course, the method is never a problem. The problem is arriving at the feasibility and also the overall reaction. Okay, guys, next. To find the overall reaction, I just have to add them up. So guys, you see 2E and this 1E, so you have to multiply this by 2 to balance the electrons. So it's gonna be what? Cu plus 2NO3 minus plus 4H plus turns into 2Cu2 plus, no, Cu2 plus, no C. Cu2 plus 2NO2 plus 2H2O. That's it. And guys, what is my E feasibility? Please add up the value. How much is it? 0.8 plus negative 0.34. The answer is positive 0.46. So guys, is this feasible? Is the reaction feasible? Yes, the reaction is feasible. So this reaction is feasible under normal condition. Why I change to negative? Because I flip the direction. Can see, when you flip the direction, you change the sign. Will the mole of electron changes the value? No, the mole of electron will never change the value. Yeah, mole of electron. Why arrow is not back and forward? Because the reaction is going this way. It will not proceed the backward. No, the Cu. No, it's fine. It's fine. You don't need to. It's okay, because I just want you to show that the go this way. It's okay. The arrow doesn't matter. That's just part of the working. Why you change the top equation but not the bottom equation? Because you are not paying attention, boy. Species that we are testing on the left-hand side, we are testing for NO3 and Cu. NO3 is already on your left-hand side. Why change the sign? You only change the sign when you are flipping the direction. See it? I highlighted it for you already. Your NO3 is already on your left-hand side. So there is no need to change the sign for NO3 minus. All right, guys, I want you guys to try this question. Go. Try this. Get the answer. Try. Now, go. Cu2 plus and I minus. No, wrong. You are not following the step right. Redo. Read the step. Read it clearly. Please, guys, follow the step. Follow the step. Oh, my girl's back. Which girl? You have so many girls.
My girls.
Oh, I thought you said I want my girls back. Come on. Which girl? You heard that also, right? So it's not my problem, it's your problem. Jennifer. Your value, positive or negative, have to indicate the sign. Thank you, Angus. Thank you, Kai-Hao. Jennifer, not quite right. Jasper, redo. Kai-Hao, correct. Agnes, correct. Haojie, the first one, as always, to get me the answer. Thank you. All right, guys, now. All right, guys, what is my first step? Guys, refer the step. Ensure the species we are testing on the left-hand side. What are we testing? If you cannot see it, you can take a highlighter to highlight it. Cu2 plus is here. I minus is here. So guys, which one to flip to your left-hand side? Why you guys go and flip your Cu2 plus? You're not supposed to flip your Cu2 plus, right? Your Cu2 plus is already on your left-hand side, isn't it? Am I right? Do you need to flip it? No need. It's already there. So you just have to copy and paste this equation. Correct. What are you flipping, guys? Right. Guys, please, this is not very difficult if you use my method. Okay, later you do past year, you will see how difficult is past year question. Okay, so guys, second, you actually need to flip your 2i minus now. You flip it, I2 plus 2e, and when you flip, the E naught value also changes to a negative. Thank you, Kwan Lang, you got it right. So guys, what is my E feasibility? add up the value is negative 0.2. So guys, is this feasible? This reaction is not feasible as the E cell is negative. Get me? Clear? All right, guys. Next, okay, this is the first condition. The first condition for it to be feasible. There's more condition for it to be feasible. The second condition for it to be feasible is the electrons must be on opposite side and cancel out. So guys, sometimes in exam, you might get your electrons on both sides and they are not cancelling each other out. If they are not cancelling each other out, they will never be feasible because the reaction must be redox. Remember, yeah? So electron must be on opposite side. I want you guys to highlight this. This is very important tip. Please, guys, this is never done in your school unless your school teacher is very hardcore like me. Very 加速 yes. 两个学生到，因为全部 online 一起教，来吧，dan. Okay, so remember. Sure, my method work for every question. Of course, my method work for every question is a challenge. My method work for every question. No matter how your school teacher design it, it's always the same. Trust me, bro. It works like a charm. Yeah. Okay, next. If electrons end up on the same side, you see, guys, will the reaction occur? No, the reaction will not occur. Please, What if you got it wrong? There's no what if. What if I get it wrong? No lah, cannot be. What if I get it wrong? No. I like you guys. What if you got it wrong? Then what you want? What you want? What if I get it wrong? How? You tell me how. This fella is always here to challenge me. You understand now, Ken? Okay, guys, we are not done with. We're gonna try the past year question. I want you guys to learn how to apply it again. Okay, electrochem, right, is all about application. You really have to try out questions, guys. Let me tell you this. Electrochem is nothing on study. The more you study, right, the more confused you get. Trust me, mark my word. You have to do a lot of questions. Okay, so guys, again, from this part onwards, right, actually your syllabus just stop here, guys. Your syllabus stop here already. Beyond this, right, it's just me being kiasu. I keep adding stuff in. Okay, so this part is never really in the syllabus. If your teacher is hardcore enough, your teacher will teach. If your teacher is not hardcore enough, the teacher will just assume you guys know how to do it in the exam. But exam question comes out like that. They need you to think outside of the box. Yeah. So this is the exam style question. All right, guys, now let's look at study tips. Hit. So far, right? Okay, I want you guys to get two concepts done. Okay, and I want you guys to get two concepts very, very clear. Yeah. Okay, if you mix up the concept, right, you cannot solve any question in the exam. Okay, guys, now the first concept that we have, right, okay, is for E cell. So guys, remember, right, my method for E cell, right, is always a husband and wife. Remember, yeah, this always a husband and wife. It's like your papa and your mama. You don't doubt them. Hey, you guys feasible or not? They already married. They 100% feasible. You don't go and ask your papa, hey, mama, you and your mama compatible or not? You feasible or not? Cannot lah. They already married. It's 100% feasible. You get me, right? Okay, so an E cell question, it's always feasible. Okay, what about divorce? No, we don't live in that era. My era no divorce. My era very traditional minded one. What is this? Okay, so it's always E more positive minus E more less positive. If there's a student with divorced parents, sorry, I don't mean to offend, but hey, my understanding, see myself and my wife, we assume we never divorce, we won't assume so, hopefully. So again, for E cell, it's a husband and wife. They are already having a reaction. You do good, ask them, hey, you guys love each other. Basically, you're seeking for trouble. Okay, so if you use this formula, guys, okay, so when you apply this formula, okay, E cell value is always positive. Remember, yeah? So 100%, right? If you use this formula, no matter what value you sub in, it will always be feasible. So don't use the wrong formula. The formula matters. So you have to identify from the question what the question is telling you. Is it telling you a husband and wife, or is it telling you a girlfriend or boyfriend? Now it's you guys. Okay, I'm gonna take two guys. Maybe we put, since we have a couple here, right? Hey, let's see who am I picking. Yes. Malcolm, you know you are Malcolm. Ask me for note, right? So you gonna now. So e-feasibility, right, is always a boyfriend and a girlfriend. Okay, so you just imagine, right? This fella, they are dating. Yes, they are dating, but you never know, right? Okay, they will be compatible or not. Okay, so they just date only. They might break up later on. You see, you guys always date for 2 months, then break up, right? See, my boy here has like how many ex? Yeah, see, exactly. Yeah, my girl here has how many ex? Because E sound negative. Okay, so again, guys, for feasibility, right, you are testing. Okay, so you are testing it. Remember, yeah. So for this one, right, you are predicting whether it will happen or not. Some keyword, right? Whether a reaction will happen or not. Understand? You yourself also not so sure. Maybe you are dating this boyfriend now, but you always doubt him. Hey, yeah, bro, is he gonna be the guy? Yeah, is it? You always doubt him. Yeah, so this is your e-feasibility. You don't go and use your husband and wife. That, hey, yeah, you are my husband. No, this is for husband and wife. You don't use the wrong formula. Okay, so you must be able to identify first. Okay, so for your e-feasibility, okay, the method is always E naught 1 plus E naught 2. Do you see a different formula right now? So if you use the wrong formula, die lah, KO lah. Okay, so the tricky part is application. You must know how to apply. Okay, so a tip is, right, ensure the species that we are testing, okay, on your left hand side, and swap the sign. Guys, for this husband and wife, right, never swap sign, please. Husband and wife formula is no brainer. Just plug in the formula immediately, you get the answer immediately. But girlfriend and boyfriend, you have to see first. You have to be like predict whether will or will not happen. Okay, by swapping the sign. Okay, sure. Okay, guys, copy down. This is very important. Later, we're gonna try some questions. I will ask you guys to think. Okay, so you guys have to tell me method one or method two, husband and wife or boyfriend, girlfriend. Done? Now, let's go. All right, guys, I want you guys to look at part three. Yes, go about. Okay, guys, now let's go. All right, kid. I want you guys to look at part three and read the question. They want you to use relevant E value, right? Is this a husband and wife, or is this a boyfriend and girlfriend? Okay, guys, remember, if you use two different methods, you will get two totally different answer. Okay, so read the question. Yes, you see, right? You guys can picture right now, right? So always remember, the moment they ask you, right, you have to ask yourself, is this a husband and wife or boyfriend and girlfriend? These two equations matters a lot, yeah, guys. Please, yeah. All right, guys, let me tell you, this is a boyfriend and girlfriend. You see whether a reaction. The questions itself also don't know whether it will occur or not. Okay, guys, more. I want you guys to look at more questions. Come, look at the board. Now look at my screen. You don't need to do anything. Just look at the screen. All right, guys, now, you see, I have this question here. Read this and read this. Please tell me, okay, on page 32, is this a boyfriend and girlfriend or husband and wife? This is a husband and wife, right? You already know they are ongoing. You can see they already having a reaction already. Page 32. So this is a husband and wife. So guys, you see, right? If you use the wrong formula, then GG already. So you have to identify first. Okay, so this is page 32. Okay, guys, I'm going to give you more. All right, guys, now, page 34. Just read this question first. Okay, I'm going to highlight all the keyword for you guys. Please tell me, is this a husband and wife or girlfriend and boyfriend? Read the highlighted part. Yes, correct. This is a husband and wife. Because you already know that they are having a spontaneous reaction. You see it, right? Do you need to swap the sign? You don't swap the sign. Remember, that is how we do it, Can. Okay, guys, now we're gonna do this question together. Guys, I want you guys to try this. Go. Try this question out. Whoever get this question right, you are very smart. Okay, very good. If you cannot get it, it's okay. Okay, this is what happens to 80% of the student in the exam. Page 37. This question is very difficult. Page 37. Okay, again, I'm gonna go through a lot of questions here. The reaction does not occur. I don't know. So I have someone say no reaction. Okay, one answer. Thank you so much. Wow, very quick. Good. All right, guys, you have to refer to the table here. Okay, guys, refer to this table here and remember my rule. Okay, this entire page, remember this rule. Remember these two rules. Okay, remember this 1, 2, 3, and try to relate all the thing that you have done in this question. Let's go. Right.
How much do you drink last time?
I start, I think, how much? 7 to 10 gram, then 5 gram every day. You have to pump it to a level 10 gram, I think, for the first week.
I'm on my first week only. I'm still on my first week.
First week, then you take 2 scoops first.
I'm on 7 grams only.
7 grams. You take 2 scoops first for 1 week, for the first week, to reach the saturation state. After that, you just maintain 1 scoop candy, just for the first week. Some people do it for 3 days. You have to take care of your protein intake if you want to go bigger. No reaction. Thank you so much. Everyone gotten no reaction. All right, guys, let's go. Sir, I beat you in arm wrestling still. Oh, you are. All right, guys, now, what are we testing? SN2+. We're going to highlight all the SN2+ first here. Okay, then we also have Cl-. Okay, that's it, guys. One more time. That's the only reaction that we have, right? Cl- and SN2+. Correct. Okay, guys. The funny thing is, right, we have 4 options here. Which equation to pick? That's the first question that you're going to ask yourself. Okay, I know that. Okay, out of these 2 reactions, you have to decide one. So, guys, we are picking the first one. Why not the second one? Second one has additional OH minus. Are we adding OH minus in any of the statement here? No, there's no OH minus added. Can see that. So there's no way you have your OH minus. So this is eliminated. I'm not using this. Okay, so I know that this is the species that we are testing, and it must be on the left-hand side. Go and flip it. So it's going to turn into a Cl minus, turns into a Cl2 plus 2E. E naught value is negative 1.36, correct? First equation done. Okay, now I have SN2 plus. Guys, the tricky part is we have two equations for SN2 plus. So which one? Alright, guys, can we use this SN2 plus? If you use this value, right, guys, we flip first, yeah? Alright, guys, if I take these two reaction, will this reaction occur? Yes or no? Are you picking the right equation? No, we are not picking the right equation. On which term? Why? Which condition is not met? Yes, the electrons are not on the opposite side. Yes, electrons on the same side will never occur. So this is also not the reaction that we are picking. You get me, right? So you have to really try out a multiple, Okay, you have to try out and eliminate other options. Okay, then finally you know that this is the reaction that we are looking at. How many times are you gonna drop your stuff today? Okay, so when you paste it over, then correct. And guys, the reason again, for previous one, the electrons are not on opposite side. Do you see that the electrons here on opposite side? Then this can occur. Okay, this is the right equation. The electron must be on opposite side. So when you add them up, so this reaction is nice because at least one of the value, both value, right? Even if you pick the wrong equation, you still get not feasible. Okay, but some value sometimes got a lie or got a trick hidden in the questions, right? If you use the wrong value, then it turns into feasible one, Okay, so yes, so your E feasibility here is how much? Negative 1.36, negative 1.5B. So I know that definitely there is no reaction. Okay, why? E cell is negative 1.5, not feasible. Sure, can we go through question part 2 as well? Can. Someone requested me to do question part 2. Guys, I'm going to slow down. As you can see, I'm not rushing because we're going to Electrochem is a lot of application. Okay, I will go slow. Okay, I'm going to go slow. Okay, and we're going to do more questions together. Do you guys still want more questions on feasibility? What if different concentration is given? Different concentration is given. There's no way to do it in your syllabus. There's no way to do it in your syllabus. There is later we will talk about different concentration. Don't worry. We'll go there. Okay, so guys, let's try 2 first, yeah? So guys, they want standard potential of E4 plus and SN2 plus and SN4 plus. So to draw a standard, first, okay, you always have to dip it into a hydrogen potential, right? We're going to draw the hydrogen first. So I'm going to draw differently this time. Okay, so this is your hydrogen, right? Your hydrogen is always 1 atm of hydrogen gas. And guys, remember, we must use a PT electrode. And your electrolyte is also 1 mole per dm cube of H plus, correct? That is connected to what? It's connected to a voltmeter, guys. Not a cell. Don't draw a cell here. It's a voltmeter, boy, girl. Please, yeah. What happened? What the gear, bro? What the gear? Actually, what the gear? What the gear is that, bro? Alright, guys, this time is also a PT electrodes because you are examining multiple oxidation state. So you must have 1 mole per dm cube of SN4 plus and also 1 mole per dm cube of SN2 plus. Do not forget short bridge in the middle. Because you are doing multiple oxidation state. Can see that? Multiple oxidation state. You shouldn't use SN tin. Okay, because it's multiple oxidation state. Okay, salt bridge, 298 cal. Done. That's how we get 3 marks. Okay. I give you guys an option. Do you guys want to try one more questions like that? Or you guys want to move on? 30 seconds. One more. Good. One more. Okay.
Yeah, how long are you gonna devour your food?
Haven't copy finish. How long am I gonna be?
That for almost 2 hours, you know.
Exactly. I'm so full.
People busy out.
Alright, guys. One more question. Hey, you. Now I'm gonna pick from past year, guys. Okay. Aiyo, how lah?
Just eat McDonald's.
Just eat McDonald's. Cannot lah like that. Cannot lah like that. See, right now I cannot find any questions any. Come out, question, come out.
Yeah.
Electron is not always PT, but if it's multiple oxidation state, then it's PT. Okay, guys, a second, yeah. I'm searching for questions here. Because some part I can't do it yet because I haven't teach. If I can't find it, then it's fine. We try later on when we. Okay, yeah. Guys, one more. This one. Let's go. Alright, guys, again, you see, let's look at the question. They want you to show that, okay, use the data to show that separate reaction of H2O2 and IO3 minus and I2 are both feasible. Page 39. Okay, you have to show that are both feasible under standard condition. Okay. So guys, let's try. Give the equation in your answer. Give the equation of H2O2 and I2. Let's go. Okay, guys, they already mentioned. Use the data. Are both feasible under standard condition. In your answer, give the equation for H2O2 and I2. Okay, so guys, I want the equation for H2O2 and I2 first. We're going to do the H2O2 and I2 first. Then we're going to try with H2O2 and IO3 minus, okay? First, let's look at your H2O2. Deng deng. Deng deng. And I'm doing for I2 first, yeah? So guys, I know that I'm swapping my I2 here, right? If I'm swapping my I2 over, it's going to be what? Negative 1.19, correct. Then H2O2, I need to use this equation, yeah? Guys, can anyone tell me why not using the next equation? Why not this equation, guys? Why don't we use H2O2 from here? No, redox can't occur. Thank you so much. Same side electrons. Well done. You see, you guys are getting better now. Nice. Well done. Good job. Yes, which is why we don't use that. You guys know that, right? Okay. Okay. So well done. Good job. Okay. Most of you guys able to do it now. I'm happy. What about O2? Where got O2? Which part has O2? It forms O2. It is not a reactant O2. Later. Don't worry. Okay, later I'll explain. So this is 1.77, right? So guys, overall equation, what is going to be? So it's going to be this reaction times 3, this reaction times, damn. This reaction times 2, this reaction times 5. So 2I2 plus 5H2O2 then turns into 2, 3, 6, 10. You still have a 6. You still have a 4H2O here. And 2, 12, 10. You still have a 2H plus here, correct? And that's it, right? I think. And you have a 2IO3 minus. That's your answer. Correct. So guys, I get my overall equation already. Guys, what is my E-feasibility? 1.77 plus negative 1.19. The answer is 0.58, right? Well done. So do you see that it's feasible? Get me? Guys, you're not done yet. That is only for one question. They want you to show H2O2 is also feasible with IO3 minus. Go. Show another equation. H2O2 with IO3 minus. But this time, half I2. Why half I2? Where half I2? Oh, yeah, half I2. Oh, sorry. Half I2 here, right? My bad. So it's just I2 here, right? Correct. Thank you so much. Alright, guys, we are done with H2O2 and I2. Now we're gonna do another one. Guys, let's do another one for H2O2 and IO3 minus, because they want you to show that. Can you see that? Go, let's do it now. Wow, so fast. Oh, cantik. Thank you, Agnes. Wow. Yeah, I never see Agnes. I only see Agnes once. Can you ask Agnes to come physical more often? Agnes, why you go TTDI cycle? She's giving me love. Hey guys, another one. Do H2O2 with IO3 minus. Do it now. This time I'm going to highlight H2O2 here and IO3 minus here. There you go. Sure, later can upload recording card, no problem. So guys, my IO3 minus is already on this side. You don't go and flip it. Don't. It's already on your left hand side. Please. Correct. What the answer, guys? Yes. So this time, kids, what the reaction will react? IO3 is gonna react with H2O from here. It's not from this reaction, guys. Why? Why do we use the first reaction? Again, electrons on the same side. Remember this. Okay, so electron must be on opposite side. So we use this equation now. Correct. And your E cell, E feasibility this time is how much? How much? Help me calculate. Oh, my mental math is not working now. 0.51, right? Do you see that it is still feasible? Understand? Are you guys getting better in doing this type of question? Sure. Go and try more, yeah. Okay. All right, guys, let's go. Okay, right now, let's look at the last part. Not last part, we still have a few more parts left. Hey, which student have my attendance here? Chunwei is here. A second, sorry, guys. Okay, let's go. All right, guys, we have E cell value, okay, of oxidizing and reducing agent. So again, right, guys, the more positive the E cell value, okay, the greater the tendency to undergo reduction and move to the right, right? Correct. It's your PR, am I right? Okay, what about the less positive the value? It's going to the left, undergo oxidation, right? Which means, guys, if you look at this entire value here, do you see that this value is the most PRR? Which means chlorine will always turn into Cl minus, right? So they always undergo reduction, which means chlorine is a good oxidizing agent. Correct? Because chlorine always undergo reduction. All right, guys, what about the negative value here? Negative value indicate that the direction always go to the left, always undergo oxidation instead, correct? Which means Mg turns into Mg2 plus by undergoing oxidation. So they are the strong reducing agent. Get me? Alright, guys, again, species on the left hand side, right, are your oxidizing agent, because they always undergo reduction, right? Species on the right hand side are reducing agent because they always undergo oxidation. Okay, acidified MnO4 is a better oxidizing agent, hence it is more likely to undergo reduction, right? So Cl minus is a better reducing agent, it is easier to undergo oxidation. Alright, guys, next. I want you guys to tell me which species is my strongest oxidizing agent? Which species is my strongest reducing agent? Huh? No, you have to refer to the value. That is AS only. Yeah, after 2 hours of eating, I'm finally done. Huh? Of course, so good.
I think it's like
I picture all the nutrients going into my body.
why 140? I don't understand.
No, it's just a baseline for me because I want to eat more. Sure, got apps. Of course, what is apps? Of course, got apps. Apps is easy. She cannot lah. Now food already. You got apps, cannot. You as long as your body fat lower than 10%, the 2 layer will show it. And then the next one, it depends on the genetic. If your genetic is good, then you can show 6, or else it's 4. Then if bad genetic, you can show 8. What the hell?
I think mine maximum 4 only.
4 is good. I think 4 is good.
6 all a bit susah lah, brother.
Huh? But the funny thing is, only guys like apps. Girls doesn't. They don't love apps. Really? Yeah, most of my gym buddy, right? Those female friends, they say, they prefer big arm, bigger chest. I don't know, man. Yeah, everyone has different perspective.
Okay, next time.
Bigger like apps.
Yeah, you like abs, right? Take off the shirt.
That's not. Haram, bro.
Ramadan.
Alright, guys, what's your answer?
Great, look good naked.
I try to look good. No, I'm going for competition.
Really?
No, it's a fitness competition, so it's not like a bodybuilding competition.
What is a fitness competition?
Uh, you guys heard of this red line?
Oh, you going for red line? Oh my god, so you do the rowing and all that?
Need to do rowing, need to do all the thingy, all the nonsense shit.
My friends all going for red line.
Alright, guys, now your strongest oxidizing agent is F2, yeah? Why? Having the highest value for your E naught, which means it's the most PR, right? Strongest reducing agent, it's your I minus. Why? Because I minus is having the least positive value. So it's the least positive value, which means it undergo oxidation, right? Kiss me? No lah. Although you look damn cute, but no. Yeah. Alright, guys, done. 41, let's go. I thought we can finish. I actually thought we can finish today. Cannot. Shit, man. Still have Nernst equations. Still have 2 subpart. Aiyo, 头痛啊. Alright, guys, again, your electron potential value, right? It will change accordingly, okay, according to the concentration, yeah. So highlight the word increase and decrease. Jasper, to answer your question, increase and decrease concentration of ions, right, cause the change in direction of equilibrium.
When you are quitting, how much water you drink?
A lot.
How much?
I think minimum. Minimum, that's a 3, I think. You're definitely drinking enough, I think. Okay, guys, we have PRR here. The rule to follow is just PRR. Alright, guys, you see, right? This is my standard E naught potential. Okay, guys, if you increase concentration of Zn, what's going to happen? So, guys, when concentration of Zn2 plus increases, direction of equilibrium will shift to the right. So, guys, remember that a forward reaction will occur, correct? So this AS, increased concentration of Zn2 plus, shifts the direction to the right. According to PRR, when the direction shifted to the right, the value becomes more positive. Am I right? Okay, because when it shifts to the right, it's always more positive. Clear? So the E naught is negative, maybe 0.56 maybe. Get me? Understand, right? So remember, guys, the rule of thumb is PRR. Just apply PR in all the question. Okay, next, guys. If you decrease the concentration, then how? Decreasing concentration of zinc, shift the direction to the left. And a backward reaction occur. So left will make the value more negative, right? So right now the value maybe turns into maybe 0.16 or maybe negative 1.06 or 1. That's it. Yeah, the material looks very flimsy. I like it. Like it looks very. No. It looks like very hard to describe. It's just nice to touch. Yeah, it's very nice to touch. Get me. Alright, so guys, if that's it, that will be all for the class today.
Okay, so that's all for today's topic. So thanks for watching.
Please like and subscribe. So someone can take it. Please like and subscribe.